All right, so Audrey, I'm going to give you the answers to the questions that you sent me in the email. On 86, first thing we're going to do is we're actually going to rewrite this and separate it out into two separate limits. All right, on the second piece of it, I am going to factor the 3 out of the limit, all right, and bring that out to the front. Now, at this point, as x goes to 5 on g of x, we're explicitly told that that equals 5. So I've got 3 times 5, or 15 in that spot. Now, on this front spot, all right, we don't have any explicit limits about as x goes to negative, as f goes to negative x, right? But we are going to look at the situation as far as we're going to x equals 5, but there's a negative in there on the x. So that's really like we're going to x equals negative 5 in the original function. All right, so what really comes into play is this first limit here, all right, which is going to be a 4, so that's going to be 19. All right, and again, we're looking at if I do the limit as x goes to negative 5 on regular f of x, that's equivalent to the limit as x goes to 5 on f of negative x. Right? Because it's all about what happens on the inside of that function, and in both of those situations, the inside of the function approaches negative 5, so they'd have the same limit. All right, looking at 87, 87 is kind of a tricky one. All right, it's a units question. So they tell us that t is in hours. All right, t is in hours, and p is in psi. All right, so they ask us f of p, all right, which equals t. So that's in hours. And they want us to find f prime of p. Now, that's really dt, so change in time, with respect to change in pressure. All right, so that's going to be hours per psi. All right, and again, it's because we're taking the derivative with respect to the variable that it's written in terms of. So that bottom of the dt over dp is going to be psi, or change in psi. So hours per psi, choice is D. Looking at 89, all right, 89 is kind of a very tricky question. All right, it tells you that you've got a closed interval from 0 to 1. All right, it tells you that 3 values are equal, and that's the output at 0, the output at 1/2, and the output at 1. All right, then they say on the open interval, and that's really the heart of the problem, and that's the key to getting this one right. All right, on the open interval from 0 to 1, f is continuous and strictly increasing. So I need something that moves up all the time and is continuous through that open. So my only option is that at each endpoint, I have an open circle on that segment. All right, because I know that the actual function's value is going to be down here at these 2 red dots at 0 and 1. All right, so I'm going to have a picture that looks something like this. Now, the curve in the middle could be anything as long as it's moving up all the time. It just can't level out. All right, so now I look at my choice. It says f attains both a maximum and a minimum value in the closed interval. All right, that one is false because we have an open circle at the top, open circle at the bottom. So there isn't a highest value we reach. There isn't a lowest value we reach. Now, that really knocks out the next two as well. All right, because if it doesn't have either one of them, then we can't have one and not the other. So we don't have either one of them. All right, so we're going to choose D, all right, which is that it has neither a maximum nor a minimum. All right, if I look at 90, all right, 90 really, right now, I would have no expectation that we'd have a way to do this particular problem. All right, but I still want to give a quick explanation just so that you kind of have from a big picture math standpoint what's going on here. All right, so this one tells you that you have conditional convergence when x equals 5. So n equals 0 to infinity of a sub n times 5 minus 1 to the n, right, converges conditionally. Right. Now, that's the sum from n equals 0 to infinity of a sub n times 4 to the n. All right, so this is converging conditionally, and that tells me that this a sub n function has to be alternating. I really don't have a choice for that, because if it doesn't alternate, then it would be an absolute convergence. It's alternating, so that's the only way you can end up with conditional convergence. Now, from there, what we might look at is we might look at, okay, let's look at this series, n equals 0 to infinity, of a sub n, plug in a negative 4 minus 1 to the n. That's sum from n equals 0 to infinity of a sub n times negative 5 to the n. Now, we know that this alternates, right? So we might be thinking, okay, well, if that alternates, I've got plus, minus, plus, minus, plus, and so on. So if this one is going to be a plus, minus, plus, minus, plus, right, for this piece, then I'm going to have positive, right, positive, 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 a non-alternating series. Right, so if I look at that, I might think, okay, well, if it was only conditionally convergent when it was the positive inside, now this time all the terms are positive, so it's not alternating anymore, so it has to be divergent. Right, and that might be a thought process that we have. The thing that we could be overlooking is possibly that first series was negative, positive, negative, positive, negative. Right? If that's the case, when I take the product of a sub n and the negative 5 to the n, I'd end up with negative, 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 negative. All right? Which right here ends up not being problematic for us at all. Those are all negative. All right? So in that case, it's not alternating either. So we end up with the series diverges. Right? So either way I look at it in terms of the alternation, we end up with the divergent series. If I have the first series, a sub n, goes negative, positive, negative, positive, negative, and the negative 5 we know goes positive, negative, positive, negative, I get all negative terms. If on the other time I have a sub n, and that one is positive, negative, positive, negative, then our negative 5 to the n is definitely positive, negative, positive, negative, which is plus, 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 plus. Right? So at that point, we could definitely choose C. There is another way to look at it with the radius of convergence. If I have a center at 1, which I know I have because I have the x minus 1 being raised to the n, right? It tells me I have conditional convergence when x equals 5, which is at 4. So out here at 4, I have conditional convergence. Conditional convergence is always going to happen at the boundary point. So if I circle that back around to the other side, right, on the other side, we're going to have our other end of the boundary, right? And this was 3 forward from 1 to 4. So I would go back 3, which would take me to a negative 2. Right? Now, I'm at negative 5, which is way back here. Right? So that's outside of my interval of convergence. Right? Because again, it's something that we would have studied if we continued on in this chapter, is that an interval of convergence, the only place that you're going to have conditional convergence is actually at the endpoints. I hope that answered, but I really, on this last one, I like looking at this analysis a little bit better, and I think that that's much more doable than looking at the interval of convergence. The interval of convergence, since we did not spend a lot of time talking about it, wouldn't be a great way to think of that one. So I'd really focus in on this, looking at the signs and what are the two options: a sub n, positive, negative, positive, negative, or a sub n, negative, positive, negative, positive. And we know what the result is for negative 5 to the n. It has to be, when I plug a 0 in, positive, 1 in, negative, and so on. All right, so I either get all negative terms or all positive terms, which means that it's got to be, it can't be alternating, so it couldn't be a conditional convergence, so therefore it would have to diverge in this case. All right, so again, C is our final answer. Don't stress too much on 90. It's definitely not something we covered, definitely not something that would be on this year's AP exam. Hope this helped.